All right, today we are doing parametrics with calculus. So all this is we're going to be taking a lot of the parametric concepts we started yesterday, looking at parametric equations, and adding calculus to it. So let's start with the idea of the slope. Normally we'd say the slope is dy over dx. In parametrics, since there's no x or x as the variable, our variable is t, we have to do dy over dt over dx over dt. So we end up with dx over dt is equal to 2t, dy over dt is equal to 3 over 2 root t, and then dy over dx would be, dx is 3 over 2 root t over 2t. And then we'd simplify this down to 3 over 4t to the 3 halves. Right? So that's the idea of the slope of dy over dx. The second derivative is of this formula. It's the derivative with respect to t of dy over dx divided by dx over dt. If you want to figure out how we got that formula, you can come and ask me. But that's the formula we're going to be using. So same exact one we just had, this equation, but now we're finding the second derivative. So we found dy over dx earlier. It was 3 over 4 root t. And then we want to take the derivative of that with respect to t and divide it by the derivative of x with respect to t, which means we're going to have divided by 2t. Then we'll figure out what that is. That's going to be 3 over 4 t to the negative 1/2. Pull it down, we get negative 3 over 8 t to the 3 halves. We combine them, get them as a common fraction, and we get negative 3 over 16 t to the 5 halves. That's the second derivative. And just like this, we can also find tangent lines. It's going to be a little bit different though, because even if we're given the x and y here, like we are in this one, we're given x is 2, y is 3. In any other case, we're just like, oh, we just need the slope. And that's true, we just need the slope. But when we go and find our slope equation, you can find it on your own. I'm just going to tell you it's going to be 2t, or sorry, t over 2 over 1 over 2 root t, which simplifies down to t to the 3 halves. So there's our slope equation, and we'll notice we need a t to find the slope. So that means we're going to take x and y and we're going to find the t that happened at. Now, because x and y are both dependent on t, we can't just plug in x and only find that one. We have to plug in both x and y and find the t that matches. So we say 2 is equal to root t, so t is equal to 4. That only has one option. More than likely, that's going to be our answer, but let's check the other one. We have 3 is equal to t squared minus 4 over 4. After some simplification, we get t equals plus or minus 4. And it says t has to be greater than 0, so it's only going to be positive 4. So t equals 4 is what matches. That's our t when this is the coordinate point we're looking for. And so we can find the slope at that. If we plug in 4 to our slope equation, we get the square root of 4 cubed, which is 8. So we have y minus 3 equals 8 times x minus 2. All right? And then we're going to move on to tangencies now. A tangency is anywhere where the vertical or horizontal movement is 0. A vertical tangency is when the change in x is 0, or dx over dt is 0, or there's no horizontal movement. As we can see, we have a vertical line and it's not moving horizontally at all. A horizontal tangency is when the horizontal movement is still going on, but there's no vertical movement, so no change in y. dy over dt is 0. So all we're going to do when we're finding the tangencies, we take the derivative. Well, that one's going to be negative 1, so that's never going to be 0. And this one is going to be t equals plus or minus 1, right? When it's equal to 0. So this one's equal to 0. Let's actually show that. All right, at t equals plus or minus 1. So there's no vertical tangencies. There's no vertical tangencies, and we have a horizontal tangency at plus or minus, or t equals plus or minus 1. The issue is, we might also want the point, so we'll also find the coordinate point for this. So we plug in positive 1, and we get 0, comma, negative 2. We plug in negative 1, we get negative 2, comma, positive 2. So we have horizontal tangencies at 0, negative 2, and negative 2, 2. Last thing we're going to look at is arc length. We've done arc length before, but now we're looking at it with a parametric. The arc length is just the square root, or the integral of the square root dx squared plus dy squared. Now technically, since we're doing this with respect to t, this is dx over dt and dy over dt. So for a problem like this, we'd have dx over dt is equal to 2t, dy over dt is equal to 12t squared. So we'd have the integral from 0 to 2 of the square root of 4t squared plus 144 t to the 4th dt. Now sometimes these are calculator questions, sometimes there's no calculator. In this case, it is going to be a calculator question. So, no calculator question, sorry. So we'll try and simplify this. I'll pull out a common factor of 4t squared. Say this is integral from 0 to 2 of square root 4t squared times 1 plus 36t squared. And that 4t squared can simplify, integral from 0 to 2 of 2t square root 1 plus 36t squared dt. Now we can do some u sub. U is going to be 1 plus 36t squared. Du is going to be 72t dt. We need a 72 on the inside, which means we need to multiply the inside by 36. So we need a 1 over 36 on the outside. New lower bound is going to be 1. New upper bound is 145. U to the 1/2 du. Integral of u to the 1/2 is 2 over 3 u to the 3/2 from 1 to 145. Simplify and plug in our upper and lower bounds. So we have 1 over 54, 145 to the 3/2 minus 1 over 54. No real way to simplify this because 1 over 145 to the 3/2 isn't a perfect square or anything. So we would just leave it like this. There's our arc length. All right. Let me know if you have any questions. You'll have a great day.